Hello everyone. In this clip, I'll cover sections 4.3 and 4.4 in continuity of 4.1 and 4.2. We'll be talking about the graphs of the trig functions. I already talked about graph of sine and cosine, so on the next two sections right here, I'll be talking about the graphs of the other four trig functions, which are tangent, cotangent, secant, and cosecant. And they have a lot of similarities, so I claim you know one, you will kind of figure out the next one. Okay, so let's talk about tangent. Y equal to tangent of x. Tangent. Don't need to write the whole word, but just TAN, tangent of x. Okay, so let's go back to the unit circle. This is my origin right here, 0, right? The angle is, instead of using theta, now our book changed to x, so I'm going to use the angle x. So you project that to the cosine axis, you got cosine x. You project it down to the sine axis, you got sine x. So that length right here will be cosine, that length right here will be sine. Now we're talking about tangent. The axis for the tangent is this vertical axis right here. So the origin for tangent is actually right here, 0, and then that line segment from here to here, the bolded green line gonna be the tangent value. Okay, so you see what? If the angle x equal to 0, tangent of 0 will be 0. And then if you all go counterclockwise, the angle x getting bigger, the tangent value getting longer and longer and longer. Okay, and what happens when x is approaching 90 degrees? Tangent x will go to positive infinity. And similarly, if you go clockwise this way, so you're going to have a negative angle for x, and then it's 0, again right here, tangent 0, right? And x is going to be a little negative number, tangent going to be going down, say another point. And if the angle is x, negative number, then tangent value will be that much for that angle. And then if x is getting close to negative pi over 2, then tangent of x is going to get close to what? That point keep moving south, right? All the way to negative infinity. Okay, that was the idea. Now let me show you guys the graph of y equal to tangent x and the xy coordinate. Let's draw it. X-axis, y-axis. Okay. 0 right here. This is pi over 2. Pi. 3 pi over 2, negative pi over 2, pi, negative 3 pi over 2. Okay, and the graph of tangent is going to look like this. Draw it a little bit better. Okay, graph will be like this. See, when x went from 0 to pi over 2, okay, from 0 to pi over 2, value of tangent will be 0 all the way to infinity, 0 all the way to infinity. X from 0 to negative pi over 2, tangent will be 0 all the way to negative infinity. And I claim that this is the entire period of the tangent function. All you have to do now is just simply copy that graph and then paste all the way to the left and to the right forever. You have the entire function. So let me redraw it. Here, keep going. Okay. Copy one more right here. Okay. All right. So there's one thing that's different from this tangent and the sine cosine functions. The tangent function have asymptote. You guys see vertical asymptote, a lot of vertical asymptote. Infinitely many vertical asymptote. At where? Negative 3 pi over 2, negative pi over 2, pi over 2. 3 pi over 2, so forth and so on. Okay. So let's write. I need some room to write. Now let me just erase one period so I have some room to write. I'm glad this won't change anything. Domain. All real numbers except. Let me see. Except what? Pi over 2 right here, plus k pi. Now let me explain to you the way we write it. See, we have a lot of exception in here. X cannot be equal to pi over 2, right? I'm sorry, pi over 2 right here, right? Because it's a vertical asymptote in there. If you jump a distance of pi, see, from pi over 2 to 3 pi over 2, you got another asymptote. And then another pi, see? And to the right as well as to the left, so pi over 2. And then what? Plus pi, plus 2 pi, plus 3 pi, plus 4 pi, you still have the asymptote. So plus k pi in general. Of course, if k is a negative number, it means that you go to the left. So in short, people write this way. It means all the numbers except for the point that pi over 2 plus a multiple of pi, where k is 1, 2, 3, 0, negative 1. All carry numbers. Okay. And tangent is an odd function. It is symmetrical about the origin. Okay. Odd function. Okay. And the range is nothing special. It goes all the way from negative infinity to positive infinity. Range is from negative infinity to positive infinity. Okay. And I claim usually people just study one period is good enough from pi over 2 to pi over 2. Okay. There's one interval from negative pi over 2 to pi over 2. It covers the whole tangent function. So the period now is not 2 pi anymore. Period is from here to here, it's just 1 pi. Okay, pi only. Fine, so good. Now, let me talk about the transformation of the tangent function. I don't think the book talked much about this, but on the previous section we talked a lot about transformation of sine and cosine, so I'll do the same thing here for tangent. So the general tangent trig function is this: y is equal to c plus a times tangent of b times x minus d. Exact same way. Okay? And a here, we don't go down to 2 anymore, I guess, but factor that the graph going to be stretching out vertically. So a is 5, tangent function stretched out 5 times taller. C here means that the graph shift up and down C unit. B here means that the graph is compressed or stretched horizontally by a factor of B, and then minus D from the x means what, move left or right B unit. Exact same thing with the sine and cosine function. The only thing different is what? The period for tangent is not 2 pi like sine and cosine. Period for tangent is just pi. So if you have a general tangent function like this, you want to find the period. You have b right here, so period is going to be pi over b, not 2 pi over b anymore. Okay? But sine and cosine 2 pi over b. Now it's just pi over b. All right, and you want to find a good interval to sketch a graph. You put the whole thing b times x minus d in between negative pi over 2 to pi over 2. All right, so negative pi over 2 less than or equal to b times x minus d less than or equal to pi over 2, and then you solve for x from here. Whatever BD if they give you, then when you simplify, and you should have a good interval for exactly one period of the graph. Okay, solve for x from there. Not hard from this, so I'll just stop right here for tangent. Now let's move on to cotangent. It's pretty much the same way. Cotangent, right? So, right. Next graph is y equal to cotangent of x, and I claim that the idea for cotangent is very, very similar. Let me use the same graph right here so we can save some time. The axis for cotangent is this way. Okay, the origin for cotangent is right here. And same p, same angle x. This point right here will be cotangent from here to here. Okay, it's cotangent. This was the tangent that we were talking about. From here to here is tangent. From here to here is cotangent. Cotangent x. So you see what? If the angle x equal to 90 degrees, cotangent is 0. If the angle is going down to 0, the cotangent point right here keep going all the way to the right. So cotangent value getting bigger and bigger. With the x angle get close to 0, cotangent will go to infinity. And similarly, if the angle x right here go this way, and you're getting close to 180 degrees, which is 1 pi, then cotangent is going to go to negative infinity. And the angle right here. This is the angle x, okay? This is cotangent x. And if angle x right here getting close to 180 degrees, which is 1 pi, then cotangent is going to go to negative infinity. Okay? Let me show you the graph of cotangent. Then we talk more about it. Just erase the whole thing faster. We have still the x-axis, the y-axis is 0 right here, pi over 2. This is pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi. I think that much good. The graph of cotangent is going to look like this, of a red color. Okay. Instead of increasing like tension, now it's decreasing, and the period is still 1 pi. But instead of negative pi over 2 to pi over 2, now it's 0 to pi, and then pi to 2 pi, and then 2 pi to 3 pi. And of course on the negative side, let's go negative pi to 0, negative 2 pi to 1 pi. Keep copy that red curve right here, pasting all the way to the right, all the way to the left. You got the entire graph for the cotangent. So the domain is all real number. Let me use the mathematical set notation instead of writing in English. Okay, all real number x cannot be equal to k pi. Okay, this means that all real number x cannot be a multiple of pi, right? Because at x equals to 0, you got a vertical asymptote. X equal to pi, another vertical asymptote, 2 pi, 3 pi, 4 pi. So asymptote negative pi, negative 2 pi. So k pi. Okay, and k is natural number. So negative 1, 0, 1, 2. Okay. And the range is nothing special, all real numbers, so from negative infinity to positive infinity. Okay. And same idea for tangent. If you do transformation, you have general formula, y equal to c plus a cotangent of b times x minus d. All right. And the period, same thing, pi over a. Okay. And if you want to find a good interval to sketch the graph, is now it's not from negative pi over 2 to pi over 2 anymore. It's from 0 to pi, right? So 0 less than equal to bx minus d less than equal to pi, and then you solve for x, you're going to have a decent interval for the period of cotangent function. Alright, that is about tangent and cotangent. Let me move on, talk about secant and cosecant. And as you can see, you learn sine, pretty much you know cosine, very similar. You learn tangent, then you can study about cotangent in a similar way. So the last section, we talk about secant, and you guys can figure out cosecant. Alright? Oh, by the way, cotangent function is also odd, right? It's an odd function. Now let's talk about cosecant and secant. Which one first doesn't matter. It's cosecant first. All right, cosecant. Cosecant of x. All right. this is how I used to think of cosecant. You know, the cosecant is the reciprocal of a sine function, so this is 1 over sine x. All right, so I was thinking of the sine function, the graph of sine x to start with. X-axis right here, y-axis, 1. Let me draw it smaller. So how about 1 right here, negative 1 right here? Okay, this is pi over 2, pi, 3 pi over 2, 2 pi, so forth and so on. And this is negative pi over 2. This is negative pi, negative 3 pi over 2, negative 2 pi, etc. And for sine function, we graph it already. Let me just sketch the graph of sine function first, and I'll show you the graph of cosecant. All right. Sine of 0 is 0. Sine of pi over 2 is 1. 0. 3 pi over 2 negative 1. Okay, so the graph will be like this. Okay. You see the period for the sine function is negative pi over 0 over 2 pi. And so when you copy a piece of graph with the interval of 2 pi and you paste this all the way to the left or to the right, you have the sine function, the entire sine function. Okay? Now, here comes the way that I think of the cosecant function. Okay? Sine is equal to 0 at those points of 1 over 0 going to be undefined. We're going to have a bunch of vertical asymptote. For cosecant function. And look, the graph of cosecant is going to look like this. So it has a lot of vertical asymptote at where 0, x equal to pi, x equal to 2 pi, x equal to 3 pi, 4 pi, so forth and so on. Okay? And on the negative side as well. And one period of cosecant function is still 2 pi. And you're going to have the entire function. You can go from negative pi to pi, you see. One piece of downward and then one piece of upward. Or you can go from 0 to 2 pi. You have 2 pieces. What? One piece of upward, one piece of downward, and then you copy the entire graph, which are 2 pieces, and then paste all the way to the right or paste all the way to the left. You have cosecant function. Okay? So looking at the graph, you can see the domain of cosecant function is what? A real number x. X cannot be equal to 0, pi, 2 pi, so x cannot be equal to k pi. Okay? Because k is a carried number, 1, 2, 3, negative, positive. Okay? What about the range? You see what happened here? Look, the y value for cosecant, or the range, the output is what? Either 1 or greater for the open up piece. But what about the other piece? It's going to be what? Either negative 1 or smaller. So the range is going to have 2 intervals, you see. Negative infinity to negative 1 in square bracket. I'm talking about that piece right here, negative infinity all the way to negative 1. And then union 1 to infinity. And that will be the range. Sine is an odd function, so cosecant is also an odd function. Okay, symmetrical about the origin. I'll just write out a general equation formula, general function, but I will not talk about this again because we've been talking a lot already. Y equal to c plus a times cosecant of b times x minus d, and that means what? Cosecant, so CSC, right? X minus d. C right here means you shift up or down. I didn't talk about it, but I just talk about it. A here means what? The amplitude. So really, A is the amplitude of the sine function. Okay. And then B here is the factor of stretching the compressor, the x coordinate, and D here means what? You shift left or right D units from the the original cosecant function. Exactly the same thing. And what about the period? Same thing as period of sine function. So it's going to be period is 2 pi over b. Sine and cosine has a period of 2 pi. This one is 2 pi as well. And if you multiply by b, period is 2 pi over b. Okay. Last one for this chapter, y equal to secant of x. Okay. And by the way, secant is 1 over cosine. And again, the way I think of it is I'll graph the cosine function, and then we'll figure out the graph of the secant function. Okay. So let's write it down here so I have more room to write. 1 over cosine of x. All right. This is the y-axis, and this is the x-axis. The origin is right here, pi over 2, pi, 3 pi over 2, 2 pi. Goes to the negative side as well, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay? And for the cosine function, it's going to look like this. Cosine of 0 is 1, it's even, so up and down. All right. Now I can draw the vertical asymptote for the secant function. Because when cosine is 0, 1 over 0 will be undefined. So it's going to be vertical asymptote for those points. All right. And of course, we're going to have graph of the cosecant function. Okay. Domain again. What? All real number x. X cannot be equal to. X cannot be equal to what? Pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2. So pi over 2 plus k pi. Okay. K is 1, 2, 3. Negative plus positive. The range. Same as the cosecant function, so negative infinity to negative 1, union from 1 to infinity. Okay. Cosine is an even function, so secant is also an even function. Reciprocal of even function is also even. Okay. And the periods for the general equation y equal to c plus a times secant of b x minus b. The period will be 2 pi over b. Same thing. Okay? Calculator. Graphing calc will be a very helpful tools for you guys to play around with this section. So, or you just Google, alright? Go to Google Chrome and then using Google to sketch a graph. Just type graph, and then you type your function or using your graphing calculator. You graph and you see the shape of the graph function, and you can learn from it. Okay, so pretty much this is the end of 4.3 and 4.4. Hope it's helped you guys to learn. Thank you for watching.